What is up YouTube? Welcome back to another episode on Code with Annie. In this episode, we're going to take a look at one more sorting algorithm in our playlist, which is nothing but the selection sort technique. Now, selection sort, like the other previous sorting techniques like bubble sort and insertion sort, is also an in-place sorting technique, which means the input array that we supply to the sorting method will be utilized and the same array will have the sorted elements inside it. So there is no additional space complexity involved, and the algorithm also works with the same time complexity as the other two algorithm, which is O of n square. Now let me explain you how the sorting happens in selection sort. Let's say you have an array of elements here represented in this example, which is 100, 20, 1, 5 and 4. Now I intend to sort this in the ascending order, which means I require 1 to come first, followed by 4, 5 and then 20 and then 100. Now in order to do this, what selection sort does is it takes the first element in the array, it assumes that this is the minimum element in the entire array. Let's say min is the value of the element, which is the minimum in the array, and min is initially assigned as 100. So what it does is min is given a value 100, and then it starts checking the elements one by one after 100 to see if anything is less than 100. So 20 is less than 100, therefore min becomes 20. Again, it goes to the next element 1, and 1 is less than 20. Therefore, min is again replaced with 1. Then we have 5 and 4, which are obviously not less than 1. Therefore, at the end of this iteration, min value is 1. So while calculating min, what I also do is I keep track of the initial element I started off with, which is 100. So I call this as position. Okay. And the position is initially 0 because this array starts at 0, right? So position is 0. And swap position is the other position which is going to go on incrementing in the array. So swap position is also initially assigned as 0. It means both of them point to the same element. So once I start iterating and start looking out for the min element, and once I identify it, so what will happen in the initial run is 20 is less than 100, therefore min is 20. Okay, and swap position will be updated to 1 because 20 is in position 1 in the array, right? Same way, when min becomes 1, which is immediately after this because 1 is less than 20, swap position will also change to 2. Okay, so likewise 5 and 4, they do not alter min, therefore they do not alter the swap position. So end of this iteration, I have min value as 1 and the position of 1, which is value 2. So this is the position of 1. Now what I will do is I will swap element at position and min swap position, meaning I will swap 100 with 1. So after the first pass, this is the array. You have 1, 20, 100, 5 and 4. Alright. So observe one thing, that after the first pass of selection sort, the smallest element in the array immediately moves and becomes the first element in the array. That means the element that is in the first position did not require any further sorting. So in the subsequent iteration, I will start with position 1, which is 20. Therefore, the position value gets incremented to 1. And the second pass, what we do is position points to 1. Okay, swap position will also be 1. Okay, because this is the initialization, right? So next iteration, position and swap position is 1, therefore I'll point to 20. And now I start comparing all the elements after 20 and see which is less than 20. So 100 is not less than 20, 5 is less than 20, therefore your min element initially, which was 20, now the min element is 5, and swap position will be 4 because 5 is in the position 4. 0, 1, 2, 3 actually, sorry, swap position is 3. Likewise, subsequently I'll see that min is 5 and 4 is less than 5, therefore again this will change. What will happen is min will become 4 and swap position will become 4. So at the end of this iteration, I will swap 4 with 20 because I will swap the element at swap position and position. So the same thing happens again. And at the end of this iteration, after second pass, what will happen is, after second pass, we have 1, 4, okay, 100, 5 and 20, right? 20 and 4 get swapped. This process will keep on repeating and after subsequent passes, which means the last pass will be when you reach the second last element, because once you reach the last element, there's nothing towards the right, and the moment you reach the second last element, your array would already be sorted. Let's look at that again. So the next position is going to be position 3, which is element 100. Therefore, I will take a look at this one in third pass. Let me do that for you. In the third pass, we have min is equal to 100, okay, and position and swap position is going to be 2, right? So we have position and swap position equal to 2, and 5 is less than 100, therefore min becomes 5, okay, and swap position becomes 0, 1, 2, 3, right? So after that, again 5 is compared with 20, because now min is compared with, so every time the min changes, the min is compared with the next element in the array, like we always have been doing, and we observe that 5 is not less than 20, therefore this is the last one, and we'll swap the elements at position 3 and position 2, which is 5 and 100. Therefore at the end of this third pass, after the third pass, we have 1, 4, 5, 100 and 20. Now if you observe where we are going with this, you can see that in the last pass, which is the fourth pass, what we do is the same thing, but this time things change again, and the min element is going to be 0, 1, 2, 3. We looked at, in the third pass we looked at position 2, right? Now we will look at position 3, and this is what we're looking at. Okay, now again the min at position 3 is 100. Again we'll compare 20 with 100. 20 is less than 100, therefore we'll do a swap, and min will be equal to 20 and swap position will be equal to 4. And then after that there's nothing to compare, so therefore we will swap element 4 with element at position 4 with element at position 3, which is nothing but 20 and 100. And after the fourth pass, we have 1, 4, 20, 5, 20 and 100, which is nothing but the sorted array. So if you look at this algorithm, it's quite simple. It starts off with the first element as min, then it compares that min against every element in the array. The moment it finds the smaller element, the min gets replaced with that particular element, and the min is compared against the next min. So basically you try to find the minimum element in each pass of this sorting algorithm. And as we go incrementally and reach towards the end of the array, we have the sorted array automatically appearing within the selection sort algorithm. I hope this video is clear for your understanding, and if you do like this video, hit the like button, subscribe to CodeWithAni if you haven't already, and I will see you guys in the next video with the Java code implementation for this selection sort. I'll see you guys in the next one. Bye bye.